Today I am going to discuss a new topic, polynomial. So in today's lecture I want to discuss what is polynomial, how polynomial equations looks like, and how we check whether the given expression is in polynomial or not. So let me start. First of all, I want to discuss what is polynomial. As you can see that polynomial is made up of two words. First one is poly and second one is nomial. Here poly means many and nomial means terms. So polynomial means many terms, and in mathematics many terms means algebraic terms. Now algebraic terms means any term which includes the product of constant and variable is known as algebraic terms. So the algebraic terms looks like 4x, 3x square as it is a product of constant and variable. So it is algebraic terms. So in simple words, what is polynomial? Polynomial is defined as an expression which contains two or more algebraic terms, right? Now, polynomials are composed of three things. Polynomial are composed of, first one is constant. Any single digit which is not used with variable is known as constant, like 5, 3, -2. Second one is variable. Variable such as x, y, z, etc. And the third one is exponent. Exponent is power, like x square, x cube. So here exponent is 2 or 3. Okay. So polynomial means any expression which contains two or more algebraic terms, and polynomials are always composed of these three things. First one is constant, second one is variable, and the third one is exponent. So how polynomial equation looks like? How polynomial in one variable equation is represented? So let us consider the general equation how polynomial in one variable is represented. Px is equals to an x to the power n plus an minus 1 x to the power n minus 1 up to a1 x plus a naught. Here a naught, this term is also written as this. Why? Because you know any variable raised to the power 0 is always equals to 1. So here a naught x naught is always equals to a naught. Why? Because x naught is always equals to 1. So this is the general equation how we represent polynomial in one variable. Here x is the variable, n is the exponent, and an in this term, an is the coefficient, and a naught is the constant term. So what is coefficient? Coefficient means any constant value used with the variable is known as coefficient. So here an is the coefficient. Why? Because it is used with the variable, and a naught is not coefficient because it is not used with the variable. It is a constant term. Okay. So let us take some example and then check how the polynomial equation looks like. Px equals to 4x square plus 3x minus 2. Is it? This is a polynomial equation? Yeah, because I already said that polynomial are composed of variables, constants and exponent. So here constant is 2, exponent is exponent is 2 and the variable is x. But what about 4? What about 3? So, one more thing, coefficient. And the coefficient I already discussed. The constant value used with the variable is known as coefficient. So here 4 is the constant value used with the variable term x. 3 is the constant value used with the variable x. So here 4, 3, these are the coefficient. So in this polynomial equation, x is the variable, 2 is the constant term. Here this 2 is the coefficient, this 2 is the exponent power, and 4 and 3 is the coefficient. Okay. Now the another thing is how we check whether the given equation is in polynomial or not. So let us consider some examples. Px equals to 4x square minus 2. Py equals to 3y cube minus 4. And pz equals to 3z to the power minus 2 plus 5. Okay. Now consider each and every equation and check whether it is in polynomial or not. Now let us start with the first equation, and the first equation is px equal to 4x square minus 2. The question is this expression is in polynomial or not? So whenever you check whether the given expression is in polynomial or not, you just check the exponent. Here the exponent is 2. Okay, and in polynomial, whenever you check the exponent are always considered as a whole number. Don't take exponent as a rational number. Don't take exponent as a real number. Okay, otherwise the given expression is not in polynomial. So in our example, 2 is a whole number, right? So the given expression is in polynomial. Okay, now let us consider another example. Py equals to 3y to the power cube minus 4. Is this expression is in polynomial? Okay, let me check. Let us check the exponent, and here the exponent is 3 and 3 is the whole number, and I already said if the exponent is not in whole number, then the expression is not in polynomial. But if the exponent is in whole number, it means the given expression is in polynomial. So this equation is also is in polynomial. Now let us consider the third example. Pz equals to 3z to the power minus 2 plus 5. Now is this expression is in polynomial? Let me check. Here the exponent is minus 2. It means 3z to the power minus 2 plus 5 can also written as 3 divided by z to the power 2 z to the power 3 divided by z to the power 2 plus 5, right? So here the variable is appear in a denominator, right? And so this expression is not in polynomial. So one important thing, please be noted that in polynomial equation, the variable terms are neither appear in a denominator nor in a radical sign. Means the variable terms are neither written as like this nor written like this. If the variable terms are appear in a denominator or the variable terms are appear under a radical sign, then the given expression is not in polynomial, but the given expression is in algebraic expression, because in algebraic expression the exponent's power are in rational number or in real number, but in polynomial the power is always considered as a whole number. If the power is not in whole number, if the exponent is not in whole number, then the given expression is not in polynomial. And this is the basic difference between the algebraic expression and between the polynomial expression. In polynomial expressions, exponent is always in a whole number, but in algebraic expressions the exponent is considered as a real number or as a rational number, right? So I think now you are able to check whether the given expression is in polynomial or not. Whenever you check whether the given expression is in polynomial, you just check the exponent. If the exponent is in whole number, the expression is polynomial. And if the expression is not in whole number, it is a real number, it is a rational number, then the given expression is algebraic expression, not polynomial expression. Okay. So in this lecture, I just tell us you that what is polynomial, how polynomial equation looks like, and how you check whether the given expression is in polynomial or is in algebraic expressions. Okay, thank you students. In tomorrow's lecture, I want to discuss what is degree of the polynomial and how we segregate the polynomial equation in terms of degree or in terms of number of terms. So, thank you.